Hey, this is Presh Talwalkar, and you're watching Mind Your Decisions. Today, Stanford ranks as one of the top universities in the world. In this video, let's take a trip back in time. Can you solve these Stanford entrance exam questions from 1892? Here's a trigonometry question. Express tangent squared of theta plus cotangent squared of theta in terms of cosine theta. Here's an advanced algebra question. If a, b, and c are in harmonical progression, prove b plus a all over b minus a plus b plus c all over b minus c is equal to 2. Can you figure it out? Give these problems a try, and when you're ready, keep watching the video for a solution. So the trigonometry question is pretty straightforward. Tangent of theta is equal to sine of theta over cosine of theta, and the cotangent of theta is the reciprocal of that. We substitute these in to tangent squared of theta plus cotangent squared of theta, and now all we need to do is simplify sine squared of theta in terms of cosine of theta. We can do this with the identity sine squared of theta is equal to 1 minus cosine squared of theta. And when we substitute that in, that's about as simplified as we can get. We have 1 minus cosine squared of theta all over cosine squared of theta plus cosine squared of theta all over 1 minus cosine squared of theta. So now let's go to the algebra question. The key part of this question is, what is a harmonic progression? I personally did not know this, and I'll admit I had to look it up. In a harmonic progression, the denominators are in an arithmetic progression. So if the first term is 1 over x, the next term is 1 over x plus d, then the next term is 1 over x plus 2d, then we have 1 over x plus 3d, and so on. Each time we're adding this common difference of d to the denominator. So we might as well say that a is equal to 1 over x, b is equal to 1 over x plus d, and c is equal to 1 over x plus 2d, for some common difference d. So we'll take this and we'll substitute it in and see if we can simplify our expression. So we first do b plus a all over b minus a. We get a kind of complicated fraction, but we can simplify it with a little trick. We'll multiply the numerator and denominator by the quantity x plus d times x. This simplifies the numerator to be x plus the quantity x plus d, and the denominator becomes x minus the quantity x plus d. The numerator becomes 2x plus d, and the denominator becomes negative d. So we have the opposite of the fraction 2x plus d all over d. Now let's simplify b plus c over b minus c. We'll substitute in our terms of the harmonic progression, and now we'll use the same trick to simplify. We'll multiply the numerator and denominator by the quantity x plus d multiplied by the quantity x plus 2d. The numerator becomes x plus 2d plus the quantity x plus d, and the denominator becomes x plus 2d minus the quantity x plus d. This simplifies to be 2x plus 3d all over d. So now we need to add these two terms together. So when we do that, we actually cancel out these 2x terms, and then we get 2d all over d, which simplifies to be 2. So we've proven that this expression simplifies to be 2. Did you figure it out? Thanks for watching this video. These math videos, which can be watched for free on YouTube, inspire and build confidence for people around the world, and they already have over 100 million views. Let's share the beauty of mathematics. With your help, we can math the world a better place. Please subscribe for free to get the news videos, watch and share all of Mind Your Decisions videos, email me a puzzle, presh@mindyourdecisions.com. If you so choose, you can check out my books, which are listed in the video description, and you can support me on Patreon for exclusive rewards. Thanks for watching, and thanks for your support.